Page 272, number 19. For the expression 5 minus 5x to have a negative value, what must be true about the value of x? I know that numbers that are less than 0 have negative values. So this expression, 5 minus 5x, must have a value that's less than 0. That would make it negative. So let's substitute some values in for x and see what happens. I like to start using simple values. So let's try putting in 1 for x, because 1 is easy to use. So 5 minus 5 times 1 would give me 5 minus 5. Well, that gives me a value of 0. And I want my value to be less than 0. So that's not going to work for me. Let's try another one that's simple. Let's try x being 0. If I have 5 minus 5 times 0, I'm going to get 5 minus 0 is this quantity, which leaves me with 5. 5 is not less than 0. So putting 0 in will not work. Let's try putting in negative 1. 5 minus 5 times negative 1. 5 minus negative 5. My rules say to change these to a positive and change that to its opposite. Well, that's going to give me 10. That's not less than 0. Well, maybe I made a mistake. Let's just try negative 2. That's easy to work with. 5 minus 5 times negative 2. 5 minus 5 times negative 2 is negative 10. Well, that's going to give me 15. I'm getting further away and more positive. So that's not going to work. So going more and more negative is not working. What about trying more and more positive? Let's try a 2. 5 minus 5 times 2. Well, 5 minus 5 times 2 is 10. Aha! Negative 5. I have a value that is negative when I put in a 2. I don't have a value that is negative when I put in a 1. Let's see what happens when I put in 1.5. A number that's in between 1 but less than 2. So when I put in 5 minus 5 times 1.5, I get 5 minus 7 5/10, and that's going to give me a negative 2 5/10. So that number, 2 works, 1 5/10 works. It looks like to me, if I need this value to be negative, x has to have a value that is greater than 1. So x must have a value greater than 1. For the expression to be negative. Number 20. Joe bought G gallons of gasoline for $2.85 per gallon and C cans of oil for $3.15 per can. Part A. What expression can be used to determine the total amount Joe spent on gasoline and oil? So, by now we recognize that when we see per something, like per gallon, and per can, that the real number that precedes that is going to be our coefficient for our variable. So I'm going to have $2.85 G for my total cost of gasoline and $3.15 C for my total cost for however many cans I am buying. So I want to find the total amount that Joe spends on gasoline and oil. So $2.85 G gasoline and $3.15 for the can of oil. And my question is asking, what is the total amount that Joe spent? And they're just asking me for the expression. What expression represents the total amount that Joe spent? So depending upon how many gallons he bought of gasoline and depending upon how many cans of oil he bought, we can use this expression to figure out the total. So that's part A. Part B. If he bought 8 4/10 gallons of gasoline and 6 cans of oil, how much will he have spent in all? So now we do have a specific quantity that we're looking for. So in part B, we're going to use the expression that we wrote in part A. So here we have $2.85 for the gallons of gasoline and $3.15 for the cans of oil. And it tells us that he bought 8 4/10 gallons of gasoline. So we're going to multiply those two together, and then we will add $3.15 times the number of cans he purchased, which was 6, and using our calculator we find that we have $23.94 for the gasoline, and for the oil $18.90. So the question asks us, how much will he have spent in all? So now we need to add those two together, and we would get $42.84 was the total that Joe spent for gas and oil. Number 21. The outside temperature was 73 degrees Fahrenheit at 1 p.m. and decreases at a rate of 1 5/10 degrees Fahrenheit each hour. That's like saying per hour. What expression can be used to determine the temperature H hours after 1 p.m.? So we're decreasing. Decreasing indicates a negative amount. We're going to be subtracting. and we're going to be subtracting 1 5/10 degrees every hour, every h. So 1 5/10 is our coefficient, h is our hours. We're going to be decreasing, and we are decreasing from a starting point of 73 degrees. So if we take the number of degrees we started with and we subtract 1 5/10 degrees every hour, we should be able to determine the temperature for a particular number of hours. And that's what they want for number 21. What is the expression?